So the next chapter we're going to take care of is we're going to take care of chapter 7. Chapter 7 deals with rationals. So we're going to look at rational expressions, we're going to look at rational equations, we're going to look at all of these different types of rationals. We're looking at probably about a week and a half maybe on this. Going to be a lot of days where you have two short videos, a kind of a part A video and a part B video to do. Sorry about that notification. I thought I shut those off, but definitely not. There's a short part A video and short part B video, and then assignments to kind of go along. So we're going to start out with section 7.1 today, rational expressions, functions, multiplying and dividing. Again, two parts. First part, the first lesson, part A, is going to be really the first three objectives: defining rational expressions. What the heck is a rational expression? Second objective, define rational functions and describe their domains. Just a little bit on that, not a whole lot on that. And then simplifying rational expressions, which is the third objective. So we got those real three objectives for today. So the first one, we're going to go ahead and define what is a rational expression. A rational expression, or algebraic fraction, is the quotient of two polynomials. So we're going to have two polynomials with making sure, again, that the denominator is not zero. So for example, x over y. You got two monomials, or monomials are polynomials, so x divided by y, or x over y. Negative a over 4. Pretty typical, you can have just a number in the numerator. M plus 4 over m plus 1. Again, keeping in mind that m plus 4, we can kind of keep those inside of parentheses because they do have to stay as a grouping of things. And so on and so forth. Remember, like the last one, x to the fifth power, that can be written as x to the fifth over 1, so it is still considered a rational expression. Now, keep in mind when we're talking about rational expressions that the denominator cannot equal 0. And by definition, a rational expression is something p divided by q. P and q are polynomials, and q cannot equal 0 in ever. So that's really the description of what a rational is. So now that we've defined it, let's talk a little bit about the domains of these things. So a function is defined as a quotient of two polynomials. It's called a rational function. Okay, so f of x equals p of x over q of x, where q does. It's the same thing. You've got kind of these two polynomials over each other. I'm going to rewrite what this says. This says 2 over x minus 5. One thing we have to keep in mind when we're talking about rational functions or rational equations is that the domain is how far this graph goes left and right. And so in most cases, you're going to have a domain that's all real numbers. And it's going to be all real numbers except for where your denominator is going to be 0. So if we look at this function, f of x is equal to 2 over x minus 5. Our domain for this is going to be all reals except for the value of x that's going to make that denominator 0. So x minus 5 can't be 0. So if x was x, then can't be 5, because if I said x equal to 5, it would give me that denominator 0. So we say that the domain of this is all reals except for x equals 5, because 5 makes that denominator 0. And we could never have a denominator of 0. So if we look at these two rational functions and we want to find ones that are really not in the domain, or what can't be in the domain. For part A, we've got x squared minus x minus 6. So if we're looking for the domain, it's all reals except for where the domain equals 0. So we would go x squared minus x minus 6, set that equal to 0. Now we're kind of back into the last unit of chapter 6 where we talked about factoring and solving. So we could factor this to x minus 3, x plus 2 equals 0. So that would mean x can't be 3 and x can't be negative 2. So if I said x is equal to 3, then that's going to make that 0. If I said x equal to negative 2, that makes that negative 0. So we say that the domain for this is all reals except x equal to 3 and x equal to negative 2. That's the domain for this one. For part B in here, there's no variable in the denominator. So since there's no variable in the denominator, it's just all real numbers. So there's really nothing to do with B on this one, right? So there's kind of that second part. The third part then is really the big part of today, is writing rational expressions in lowest terms. So we want to be able to essentially simplify rational expressions, okay? So something in simplified form, that's a fundamental. Again, we won't worry about this. Writing them in lowest terms, kind of the steps to putting them in lowest terms. Step one is to factor both the numerator and denominator, and then cancel anything out that can be canceled out. Okay, so let's look at some examples. So these two are rational expressions. We've got y squared plus 2y minus 3 over y squared minus 3y plus 2. We're going to take and go ahead with these two things, and we're going to factor if they can be factored. So if we look at the top one, it's a trinomial. So we've got negative 3 on the top and 2 on the bottom. So that's positive 3, negative 1. So the top one factors into y plus 3 and y minus 1. So that's what the numerator, top one, numerator, factors into. The bottom one, or the denominator, we've got a 2 on the top and a negative 3, so negative 2 and negative 1. So that's y minus 2 and y minus 1. Now you'll notice that we have both the y minus 1 both in the numerator and in the denominator. Those two things are then going to divide each other out. We can cancel both of those out. So our solution to this in lowest terms is y plus 3 over y plus 2. Now, one thing you can't do is these have to be considered a grouping of things. Okay, so you cannot cross those y's out, because order of operations says that we have to add on top first. We'd have to combine the y plus 3. So we cannot cancel out. Just like at the beginning, you couldn't have crossed out those y squareds, or you couldn't have crossed out those y's. You can't do that. If it's a polynomial and you have, so if you have anything added or subtracted, either in the numerator or the denominator, you just kind of have to leave them alone. You can't automatically cross them out. So this is our solution to that, and you're done. Now, there are exceptions. We could figure out what y values couldn't be, but we're not going to worry about the domain right now. It's not asking us. Second one, y plus 2 over y squared plus 4. Right? We factor the top, it's already factored. We look at the denominator, it's already factored. So both of these are already factored. Since we've got y plus 2, we can't cancel anything out. We've got y squared plus 4, we can't cancel anything out. So that's your expression in lowest terms. There's nothing you can do with that one. And that one's done. Okay. So we've got 1 plus p cubed over 1 plus p. So we've got a difference of cubes on the top. And we talked about difference of cubes in the last unit. And we said that difference of cubes was a plus b times a squared plus ab plus b squared. So my a value is 1. My b value is p. So this would be 1 plus p times 1 plus p squared over 1 plus p. We've got 1 plus p there, 1 plus p there. So our solution is 1 plus p squared. And I don't think we have any of these in our assignment for today, but that's, again, that's that sum of cubes. And I think this should be a minus. My apologies. This should be a minus. So that should be a minus right there, and that should be a minus. Sorry about that. So that's that one. Now again, just like I said, be careful. When you use the fundamental property of rational numbers, only common factors may be divided. For example, y minus 2 over 2 does not just equal y. Okay? And it doesn't just equal y minus 1. You can't do that. Because the 2 in y minus 2 is not a factor of the numerator, remember to be a factor before writing the fraction in lowest terms. So you would have to factor things. Okay? And they kind of give an example of why you can do that. So you just can't cancel things out. Okay? They have to be exactly the same in the numerator and in the denominator. Okay, so let's take a look at these two. We've got r minus 1 over 1 minus r. Are they the same thing? No, they're not really the same thing, but here's a little trick. Notice they're opposites of each other. If I factor out a negative 1 out of there, that gives me negative 1 plus r. So really what I have here is I have r minus 1 over negative 1 times r minus 1. So now these r minus 1s can cancel each other out, leaving you with just an answer of negative 1. It's kind of, if you see that opposite thing in there, multiply it by, factor out a negative 1, and it becomes the same, and they can cross each other out. You just got to leave that negative out there somewhere. Okay? P minus 2 over 4 minus p squared. Kind of the same thing a little bit. We can't do anything to the top, so that's just p minus 2. On the bottom, it's a difference of squares. So the square root of 4 is 2. The square root of p squared is p. So that's 2 minus p times, oops. It's 2 minus p times 2 plus p. And again, if you notice, this one here and this one here are opposites of each other. So I can essentially factor out a negative out of there. So we would have p minus 2 over negative 1 times negative 2 plus p, which is that same thing. And then we've got 2 plus p. So our solution to this is 1 over negative 2 plus p. It's kind of that opposite thing here, and it happens, and it can happen quite a bit. I think I tried to eliminate a lot of those in the assignment for today, but that's something that certainly can and does happen every once in a while. Okay, so just kind of the quotient of opposites. So in general, if a numerator and a denominator of an irrational expression are opposites, then the expression equals negative 1. So for example, if you had p minus 1 and 1 minus p, the numerator and the denominator are opposites of each other, so then this is going to equal negative 1. Okay? And it's kind of what they say in that one. Okay? So I want to do a couple more examples to make sure we're good to go with this, and then we'll end this video and kind of go on to the next one. So let's look at, let's go y minus 5 times y plus 2 over y plus 2 times y minus 4. And we're going to simplify this. So we've got a y plus 2 in both the numerator and denominator. So those are going to divide each other out, leaving me with y minus 5 over y minus 4. Nice 4. And that's your solution. Okay. Let's look at one more. Y squared minus 10y plus 25 over y squared plus y minus 30. So we're going to simplify this. So we've got something going on in the numerator and denominator, so we need to factor. Use the x method. C value goes on the top, b value goes on the bottom. So we need two numbers that multiply to be 25 and add together to be negative 10. So negative 5 and negative 5. So this factored is y minus 5 times y minus 5. The bottom, it's negative 30 and 1. So 6 and negative 5. So y minus 5 times y plus 6. The y minus 5s are going to eliminate each other, leaving me with y minus 5 over y plus 6. And there's a solution. Okay, so there's the first part of section 7.1. That's part A. I would kind of stop. I'm going to stop the video here, and then we'll do a second video for part B. I would go ahead and finish the 7.1a. I would go ahead and do the 7.1a homework right now, get that done, and then watch the 7.1b video and go from there. So, simplifying rational expressions and defining them, section 7.1a.